I'm sure that all of you have heard about the new match statement available from Python 3.10, but do you really know how to take full advantage of it? Maybe not. That's why I made this guide that will walk you through all the things that you need to know to master it. So if you're using VS Code, you need to install the extension Pylons first. So you need to go here, Pylons, like that, and install it. Okay, I've already installed it. And also you need to go to the settings, down here, settings, then you can write Python, you go down, until you find language server. It needs to be default or Pylons, not this one, okay? And why? Because basically the match statement is not supported by JDI. So you would get with errors like a red underline because it doesn't recognize it and stuff like that. So the match statement is made up of an expression, which is called subject, and different patterns, okay? Each pattern will have a piece of code to run if the subject matches it. So first of all, I want to point out that the match statement uses the if, elif, and else statement under the hood, which means that it doesn't really improve the speed of your code, and I've actually tested it. So it could be a really powerful tool to have in your tool belt, but don't think that from now on you need to use it all the time, okay, instead of the classic if, elif, and else statement, okay? Use the one that makes more sense to you in that specific scenario, okay? So let's first see the syntax to use with a really simple example, and then we're gonna move on to more advanced things, okay? So let's say we've got a variable, myvar, okay? And then a, for example, and then x, which is 10, okay? So we're gonna do something like match myvar, which is the subject that will be evaluated, and then the case, for example, a, print a. This means that basically Python is going to compare this, the value of this variable, with this. If the two are equal, then this is run, and all the other cases down here will be ignored. So let's say we've got another case, print b, okay? So let's try to run it. Let's see what we've got. So Python match statement. As you can see, a, if this were 2, b, sorry, this is b, okay? Pretty straightforward. And this is basically the simplest pattern, which is called literal pattern. So strings, numbers, booleans, etc., all kind of literals. You cannot use f strings, so you cannot do something like f, okay? The f string is not allowed here. And as I said, you can use numbers, you can use true, something like that, okay? So let's stick to a and b. Okay, so you can also use guards as part of the case, and the guards are something like this. So let's actually see an example. If x greater than 5, okay? So basically this is like if my var is equal to a and x is greater than 5, do that. Elif my var equals b, then print b. In this case, you've got a, because we're gonna change that, you've got a, and then x is greater than 5. So if you run that, you get a. But if, let's say, this is 11, you get nothing, because you've got a, and this is here, but you don't have x greater than 11. But if this were b, of course, you get b, okay? Then, in case you want to use a simple conditional statement, okay, so you just want to check if my var is greater than 10, for example, you just need to do something like my var, okay, and then here, my var greater than 10. So if my var were 12, that would print a, okay, as you can see, perfect. This is sort of an if statement. It doesn't make a lot of sense to use it like that, because I would use an if statement, an if, elif, and else statement in this case, but I'm just telling you what you can do, and then you can decide which way is better in a specific scenario, okay? So then, if you want to run the same piece of code, if one condition or the other matches, so a sort of or statement, if something or something else, you need to use a vertical bar, okay? So let's actually go back to the case like that, a. So you can do something like a, vertical bar, b, okay, run a, b, okay, and here you can write c, for example, okay. So if my var is A, this is going to print AB, as you can see, and then also with B, same thing, AB. Okay, so this or this, and you can have a lot of others here. Could be C, etc., etc. Okay, perfect. And apart from the O, you can have also the S pattern. So this is an O pattern, and you've got the S pattern as well, okay, which is used to bind the subject, okay, the value of this, to the name after the S keyword. So let's see what I mean. If you do something like as value here, so basically, if my var is C, then the C, okay, the value of the subject is bound to the value variable, and then you can use it down here, like this, okay? So if this is C, as you can see, you get C because you're printing the value, okay? But this is more useful when it comes to more than one value, like in this case with the O, because in this case, you know for sure that you've got a C, okay? So you can just write C because it's like, yeah, I know that this is the C. But in this case, you don't know if this is an A or a B. So you can use as value here. And this, if my var is A, then value is A. If my var is B, then value is B, okay? So you can do something like that, and you can see that if this is A, you get A. If this is B, of course, you get B. Really, really cool, okay? Now you might be wondering, what if none of those are valid, okay? Is there a way to actually run something when all of the cases don't match, basically? Yes, there is, and this is a wildcard, which is an underscore, and this runs if none of the, if this is not A or B, and this is not C, you know, the value of my var, then this is used, and this is a sort of else. So elif C else, print none of the above, okay? So let's say you've got P, something like that, you'll see that none of the above, okay? Really, really cool. And instead of using the underscore, you can just use a variable, as we did earlier. You can use value, you can use whatever name. I'm using value, but you can use something else, okay? And then you can use the value here, okay? So you could write something like this value is not allowed, or something like that. And in fact, you print P, okay? And this is called a capture pattern, okay? Because basically it captures the value of the subject, and we'll actually see more about it later on, okay? So all of this could be written in a function, okay? So you could do something like def check var, and then variable, something like that. Then you could do like that, variable, okay? So instead of writing this all the time, you can just do something like check variable, and then my var, and then you get the same thing. You can even return here. You can do something like return value, you know, you can do whatever you want, okay? So this is a function that you can call whenever you want to check if a variable is something or something else, etc. But in this video, I'm not going to use the function, but this is just to show you that you can use it. So before we dive into more complex cases, let's recap what you've learned so far, okay? You've learned about the syntax, you've learned about the guards, or and as patterns, wildcards, capture patterns, and how to implement everything with a function, okay? Of course, these examples are basic, but of course, now you know that you can do that. You can use the match statement, or you can use the if, elif, and else statement, okay? The one that makes more sense to you, knowing that you don't really get an increment in performance using this statement. So if you use this, or if you use if, elif, and else, the performance and the speed is roughly the same, okay? So the match statements are so much more useful when it comes to sequence, mapping, or class patterns. Let's see actually an example with a tuple, but it could be also a list, for example. So let's delete all of this like that, okay? So let's say we've got a tuple like that, 1, 2, and 3, okay? And then we want to use the match statement on that tuple. So my tuple like that. Then case 1, 2, 3, print just 1, okay? Just to do something. So in this case, this matches a tuple with 3 elements, so length 3, and they need to be 1, 2, 3 in this order, okay? So basically here you test the length and also the values, which could have been done with the if, elif, etc. But this is so much better, okay? Because you just need to write it and that's fine, okay? Then you can have like case 1, 2, 3, 4, and then you print 2 like that. We can actually try to run it. As you can see, you get 1, but if this is 4, you get 2, and if this is like that, you don't get anything because this and this are not equal to this. Really, really cool. You can even do groups, okay? So let's say I want to match a tuple with 1, then 2, 3, 4, 5, which means this needs to be a tuple with 1, 2, 3, and 4 elements. The second element could be either a 2 or a 3, okay? Of course, let's print something. Let's print 3. In this case, let's try with a 2. As you can see, that works, but this could even be 3, and this works as well, okay? Really, really cool. So, as we did earlier, if you use the keyword as, you can see if this is a 2 or a 3, okay? So here you could do something like as num, and here you can print the num, okay? So basically you get 3 because this is a 3, and you get 2 because this is a 2, okay? This could be really, really useful. Then capture patterns are useful here as well, because you could maybe do something like this. So let's actually delete all of that like this. You could do something like 1, then element, okay, and then 3, and then you can use element down here. This basically tells Python this needs to be a tuple with 3 elements inside. The first element needs to be 1, the last element needs to be 3, and the middle element could be whatever. So here you could do something like even like a string like that, then 3, and this would work. As you can see, that works, okay? Because here you are not telling Python what you need here. You're just telling Python you need an element here, but you could even use another name like var, okay? This is just a name. So you can use the capture pattern to tell Python, yeah, just I want this length, but I don't care about the element in the middle. And you could even do something like var1, var2, var3. So basically here you're just telling Python, I want a tuple with 3 elements, but I don't care what is this, what is this, or what is this. And in fact, this works because I've printed the var1, okay? So capture patterns are really, really cool if you want to be able to get the element, but also to tell Python about the length of a specific tuple, a specific sequence, because this could be a list as well. So basically this is sort of unpacking the tuple because you're doing var1, var2, var3, and then the tuple, okay? One important thing is that those names, as you can see, I've written var1, var2, var3 because they need to be unique. So you cannot have var1 and var1 here. If you don't want to capture the value and you just want, to tell Python about the length, you can use the wildcard like this, okay? And this, of course, here, let's just print A, okay? So here you're telling Python 4 elements, you're not capturing them, okay? You're just telling Python the length. And by doing this, you don't need to do like var1, var2, var3, var4, etc. But you can use as many as you want without worrying about repeating it. On the other hand, if you don't want to have a fixed length, because here we've got a fixed length for elements, basically, you need to use the star pattern, okay? And you can use it only once in the sequence. Let's see what I mean. So let's delete that. So the star pattern works like this: 1, 2, and then others. As I've said about the other name, here you can write whatever you want, okay? And then you can print, let's actually print others. So what you're telling Python here is that you want the first element to be 1, the second element to be 2, and then you can have as many elements as you want, and you don't actually care about that. And this is actually a list of all the remaining elements. So let's actually try that. So you've got 1, 2, 3, 4, string, something like that, okay? If you run that, you can see 3, 4 string, okay, because 1, 2, they are there, and then all the others. So the others are 3, 4 and string, and you've got the list. And then down here you can use like 4 element in others, do something and whatever. So here you're just telling Python that you just care about the 2 elements here and you don't care about the others. Of course, the start button could be wherever, okay? You could put it here, for example, like this, and this would work just if the last elements are 1 and 2, or just you can do that in the middle. So you could have like 10 elements in the middle, but the first element needs to be 1 and the last element needs to be 2. Okay, really, really important. And of course you can combine the captcha pattern with the start button. So here you can do something like first and then use others and first whatever. Okay, you can mix up things however you want. The first element now could be whatever. Okay, it could be 1, 2, 10, whatever, string. Okay, by the way, one thing that I haven't mentioned is that you can actually use an O pattern here. So you can do something like 1, first, others, okay, something like that. So basically this case succeeds if my tuple matches this one or this one. An important thing is that you need to use the same name, so you cannot use second here, okay, as you can see. Okay, so you need the same names, and if you don't have names and you just have like 1, 2, 3 and maybe 3, 4, 5, for example, this of course is not a problem because you don't have any sort of variable. So keep in mind that you need to have the same names, first others in both patterns. Okay, perfect. Let's actually go back to this like that. Okay, so this is basically what you can do with the sequence pattern. But what about the mapping pattern for dictionaries and stuff like that? First of all, there are a few differences. The length is not checked. Okay, so let's actually see an example to make it clearer. So my dictionary, something like that, and then we can do something like key 1, key 2, then 2. And also let's say you've got also a key 3. Okay, so okay, then we can do something like my dictionary, okay, and then case, and you start writing key 1 and then key 2, something like this, and we want to print something, okay, something like that. Okay, as you can see, you get okay, but you didn't write all of the key value pairs, you just written these two, because as I said, the dictionary in this mapping pattern, Python doesn't check the length, okay, and it doesn't even check the order. So if here we've got 2, and then here key 1 and key 1, this works as well. Okay, basically Python checks if all the keys here are inside the dictionary, and if the values are equal to these values, then this is fine, even if you've got a lot of more key value pairs left. Okay, and as you could see, the key 3 has been ignored, okay, because we didn't use a double star pattern, which is the same as the other pattern, the star pattern, but for mapping patterns. Okay, so you could do something like others, okay, and then here print others like that, and as you can see, you get key 3. So others is a dictionary containing all the remaining keys that you didn't specify in here. Okay, and as the order is not important, the others cannot be put here, okay, because it doesn't make sense. You need to put it at the end of the dictionary like that. Okay, this is really important. And in the dictionary, you can use the as keyword as well, okay, which is kind of cool because you can do something like key 2, and then you can print the key 2 here, okay, and you get this value, you get 2, okay, so as you can see, you get 2. So basically, if you want to use the value down here, you can just do as key 2. And of course, this would make more sense if you had an O pattern here. So like 2 or 3 or string or whatever, okay? Because in this case, you don't know if the value of key 2 is 2 or 3 or string. And by doing as key 2, then key 2 will hold the value, will hold 2 or 3 or string accordingly. Okay, let's actually go back to this. Okay, so you got your 2 like that, and you can of course use the capture pattern. So here, instead of writing this, you can do something like value key 2, something like that. Okay, and then here you write value key 2, and this could be whatever. Okay, it could be 2, it could be 10, etc. So if you change this to 22, for example, this still succeeds, and you get 22 here because you captured the value basically. And of course, this could be whatever. It could be a list, it could be a string, it could be anything. Okay, and then you can even use more than one dictionary, for example, here, like tuples or lists in the sequence pattern. Let's copy this just to speed up things a little bit, like that. Okay, so here you could do something like key 1, key 4, I don't know, something like that. Okay, so here this case succeeds if this matches this, or if this matches this. Okay, so you can have more than one dictionary to compare in the same case. Okay, and the variables, the names, needs to be the same as we saw for the tuples. So value key 2 needs to be in here as well. If you don't have value key 2, but you've got just another value, you get this error. So you need to have this name and this name in this dictionary as well. Okay, so you need something like this for it to work, or maybe something like this, that would work. Okay, if you have a capture pattern, which is a variable that like this that captures the value, you need to have it in all the patterns. Okay, even here like that. Okay, so really important to know that. Okay, and then let's move on to the other really interesting pattern, which is the class pattern, and this is really useful and really powerful. Okay, but before we dive into that, if you're still watching, definitely leave a comment down below so that I know that you got to this point, which means you're finding this really helpful. Okay, so let's move on to the class pattern. So let's say I've got a class person. Okay, class person, and then I've got a name, class attribute name, Jack, and an age 35. Okay, perfect. So then I create a person instance, person like this. Okay, and then I can do something like match person, so the instance, and then look here, because this is phenomenal, case person like that, print it is a person. Basically, this would use the is instance to check if the subject, this, is an instance of this class, of the person class, and if so, it succeeds. Okay, so in this case, as you can see, it could have been name whatever, age whatever, this is still a person, so a person object, and this succeeds. Then you could have other cases, and as we did with dictionaries, you can just write an attribute and the others are ignored. I'm going to write it up here because this would always match before the others because you didn't specify any attribute, etc. So I'm going to write it up here. Okay, so person, then you can specify the name, for example, something like name Jack, okay, and print I am Jack, something like that. Okay, and of course this would succeed. Okay, if the name were John, of course this wouldn't succeed, and as you can see, it is a person. Okay, let's switch back to Jack for the moment. Then you can do something like also the age 35. Okay, this would match this person if, of course, the name is Jack and the age is 35. Okay, I'm not going to run it. The only important thing is that the number of the attributes that you write here needs to be the same as the number of the attributes of the person, because you cannot do something like surname, something like that, because you don't have enough attributes. Okay, perfect. Here you can use the capture patterns as well. Okay, so if you don't want to specify, let's say, a name, but you just want the age, you do something like that, and then down here you can specify the name, for example, and this of course would be Jack. If this were John, that would be John, etc. So you're just checking the age. You can just do something like that. So any name or any age is fine. Okay, and you can print it. Quite cool. Okay, and of course, as we've done for the dictionaries that I told you that this works for sequences as well. You can use something like this. So you can have like Jack, like that, okay, and then another person object with another name, so something like John, okay. Of course, this just A, something like that. So this would match a person with the name Jack or a person with the name John, okay. Either of them would match, okay. And of course, in this case, since the class is the same, okay, we're not checking like person and then here, like let's say dog or something like that, but we still have the class person. We're just checking a different name. So name Jack and name John, okay. You could do something like this. You can do something like name Jack or John, okay, something like that. And this would work the same, okay, because there's person named Jack, person named John. In this case, person named Jack or John or whatever, okay. You can add other names here, okay. And of course, here you can use the as keyword as well. So like as name, and then you can see if the name is Jack or John, okay. So let's actually go back to that. But of course, if you had different things like person, dog, I don't know, and maybe like just a string here, okay, something like that, of course, you need to do that this way, okay. Let's actually go back like that. So far we've just used keyword arguments, so name, age, etc. But what if we want to use positional arguments? So something like this, something like person, then Jack, something like that. Instead of specifying like name equals Jack, just Jack, okay. And to do this, we need to specify the order. Otherwise, Python wouldn't be able to know if this is the name or this is the age, etc., and that would throw an error. So we can actually try to run it. You can see what I mean, okay. As you can see, person, 0 positional arguments, 1 given, okay. So there is an attribute you can add to the person class to specify the order, which is underscore match underscore args underscore, and you can do something like a tuple, name, and age, okay. In this case, you see that this works. It prints A because you're specifying this is the first argument and this is the second. So if here we were to write 45, this would work as well. As you can see, it doesn't throw an error, okay. And if you write 35, of course, this would print the A, okay. So this is a way you can use positional arguments, but you need to specify the order in here. So you could even have like age here and the name after, okay. In this case, you need to write the age here and the name here, okay. As you can see now, you can use positional arguments without specifying the attribute every time. And of course, if you specify, it doesn't matter, it still works, okay? I haven't mentioned that you can use the as keyword as well. So here you can use as name, for example. You can then use the name down here, okay? So the as keyword, you can use the as keyword everywhere, okay? Like here, as age, something like that, okay? This would work, but it's definitely more useful when you have a no pattern, as I've shown you earlier. So if here you had John, okay, as name, that would make more sense. Like that, okay. And of course, with all these advanced patterns, you can still use guards, okay? And you can even nest objects like a list containing other lists or a list containing person objects, for example, and stuff like that. Let's actually see a quick example. So let's say that, let's keep that, okay? So let's say that we've got a list of person objects, person like that, and then person like that, okay? Then we can do something like match people, okay? So you're matching the list. I can do something like case, the empty list, which means that you don't have anything in here, and this we can do something like no one, okay? Then you can do something like case person, okay, name Jack, something like that. You can even use as Jack, okay? Then you can use it print, you can print Jack. this doesn't work actually, because you've got just one person. So here we've got 2 people, and here you've got just one person in the list. So it expects just one person. So we can do something like this, and this would work. You can see you get a person object, okay? But if we do something like case, okay, so person like that, okay, then name Jack, and then just a person, just person here, and we print something like 2 people. Here we can have person like that, okay? So here Python checks if you've got a list of 2 people, one person needs to have the name Jack, and the other person is fine, could be any name, okay? So let's write it. As you can see, it didn't work because here we've got the uppercase J, so we need to write Jack like that. Okay, so if we run that, now you get 2 people. Okay, down here you can then use a wildcard, like print something. Okay, just, you know, just a fallback code. Of course, here you can use everything I taught you. You can capture an attribute like the age, use it, capture both the name and the name here. You can capture it. Instead of having Jack, you can do something like name and then whatever. Okay, all the things that I've taught you for sequences and for dictionaries work here as well. Okay, and everything could have been written with an if, elif, and else statement, but especially for the more advanced patterns, this really makes things easier to write and definitely cleaner. Because, for example, for the last example, for this here, you would have had to check the length of the list, then use isInstance to check the instance, and then, you know, check the attributes, etc., etc. And using the match statement, you can just write something like this, and this is so much easier, okay? Next week, I'll post a video on how to use the match statement in a real program. If you're interested, make sure you subscribe to get notified. If you're watching this and the video is already out, you should see it now on the screen. If not, no worries, this other video is worth watching too.